Okay, today we're going to be starting Unit 3. Unit 3 is about using and proving trigonometric identities. So we'll start out by talking about what an identity is. An identity is any statement that two expressions are equal for all values of the variable for which the expressions are defined. Identities can be shown to be true or proven. When we prove an identity, we're going to start with one side of the equation and re-express it until it is transformed into the other. Very often, we will not give supporting reasons as we did in geometric proof as long as all the steps are shown. So the key here is showing all of your work. So let me give you an example of an algebraic proof. 3 times the quantity 2 minus x plus x should be equal to 2 times 3 minus x. So what we'll do is we'll start with one side of the equation, 3 times 2 minus x plus x, and I'm not going to write the other side of the equation because if I did, after the equal sign, we would have nowhere to go. In fact, I would be saying I've already proven it, which I haven't. So what I'm going to do with the left side of the equation is I'm going to transform it using operations and properties that we are familiar with in algebra. So first thing that I will do is distribute the 3 into the parentheses, and we'll get 6 minus 3x plus x. So I've transformed it using one property, the distributive property. The next thing that I'm going to do is to combine like terms together. So that'll give us a next step of 6 minus 2x. Now, typically, the next transformation that I make, I'm going to write underneath. And then let's look at what we're aiming for. We are aiming for this to be equal to 2 times 3 minus x. So the only step that's left to do is to undistribute or to factor out a 2 from the quantity 6 minus 2x. If we do that, we get 2 times 3 minus x. And if you draw an arrow down on the left side of the equation, we can have brought that side down for each step. So 3 times the quantity 2 minus x plus x was just proven to equal 2 times the quantity 3 minus x. Very often after a proof, you might write QED, which in Latin stands for quod est demonstratum, or more or less, it has been now demonstrated. Let's take a look at some identities that we are familiar with so far. There are the reciprocal identities. And while you think of only 3 reciprocal pairs, we can express them using 6 different equations. While sine of theta is equal to 1 over cosecant of theta is also equal to 1 over sine theta. Then there are the quotient identities, and the quotient identities are for tangent and cotangent. Since those are expressed as a division, tangent is sine over cosine, and since cotangent is tangent's reciprocal, cotangent is cosine over sine. Another trigonometric identity comes from the unit circle. So you will remember this drawing of the unit circle, and I'm always wanting to think about when we start at the origin, how we get to a point x comma y. That is, I'm going to travel over an amount x, and I'm going to travel up an amount y in order to get from the origin to the point x comma y. We also need to remember that the unit circle has a radius of 1, so I'm going to label the hypotenuse of this right triangle, or the radius of the circle, 1. Now, if we look at the sides of that right triangle that we've just labeled, there's a relationship among those 3 sides given by the Pythagorean Theorem, and that relationship is x squared plus y squared is equal to 1 squared, and 1 squared is 1. You might recognize that equation as the equation of a circle centered at the origin with a radius of 1. You'll remember that from Algebra 2. That also gives rise to a Pythagorean identity using trigonometry, because on the unit circle, we'll remember that the x-coordinate is also cosine of theta, and the y-coordinate is also sine of theta. So if I write that same relationship using the trigonometric expressions instead of x and y, we can write that sine squared of theta plus cosine squared of theta is equal to 1. There are two other Pythagorean identities that I do not advise that you memorize. I do advise that you memorize this first one, sine squared of theta plus cosine squared of theta is equal to 1, but we can always generate the other two by division. If I divide the original Pythagorean identity, sine squared plus cosine squared of theta equals 1, by cosine squared, I'll distribute that division to all of the terms on the left side, and then re-express all of the terms in that equation. If you'll remember that sine over cosine was equal to tangent, so sine squared over cosine squared is equal to tangent squared of theta. Cosine squared of theta plus over cosine squared of theta is equal to 1. You also remember that the reciprocal function for cosine is secant, so 1 over cosine squared of theta is equal to secant squared of theta. Now we have another Pythagorean identity that involves the tangent and the secant functions. I'll start again with the Pythagorean identity sine squared of theta plus cosine squared of theta is equal to 1, and this time I'll divide all of the terms by sine squared of theta. Sine squared of theta over sine squared of theta is 1. Cosine squared of theta over sine squared of theta is the square of cosine over sine, which is the cotangent function. So cosine squared of theta over sine squared of theta is equal to cotangent squared of theta. And 1 over sine squared of theta is equal to cosecant squared of theta. So we have three Pythagorean identities, only one of which you're going to memorize. When using a Pythagorean identity to find the value of a trigonometric function, keep in mind that the signs of the three principal trigonometric functions are given by the mnemonic all students take calculus. So if I use the first letter of that mnemonic in each quadrant, in the first quadrant I'll write an A, second S, third T, and fourth C. What this means is that for any angle that terminates in quadrant 1, or equivalently an angle between 0 and pi over 2, that all trig functions are positive. For an angle that terminates in quadrant 2, or equivalently an angle between pi over 2 and pi, only the sine function and parenthetically its reciprocal, the cosecant function, are positive. For an angle that terminates in quadrant 3, or equivalently an angle between pi and 3 pi over 2, only the tangent function and its reciprocal are positive. And for an angle that terminates in quadrant 4, or an angle between 3 pi over 2 and 2 pi radians, only cosine and its reciprocal, secant, are positive. That gives us a quick way to determine whether a function is positive or negative. So in example 2, part A, we are given some information about a secant of an angle, and we're asked for cosine. We may not actually need the additional information because there's a very direct relationship between the secant function and the cosine function. That is to say that the cosine function is 1 over the secant function. So cosine of theta is 1 over 3/2, and 1 divided by 3/2 is 2/3. In part B, we are given information about a sine of an angle, and we're asked for the cosine of the angle. We can use the trigonometric, the Pythagorean identity, that is to say that sine squared of theta plus cosine squared of theta is equal to 1. And if the sine of theta is 1/2, then sine squared of theta is 1/2 squared, which is 1/4. Subtracting 1/4 from both sides, we get cosine squared of theta is equal to 3/4. Then we can take a square root. Now you'll remember from algebra that if we take a square root, we get two solutions for cosine of theta. Cosine of theta is plus or minus the square root of 3 over 2. Here's where we have to decide whether it's plus or minus. And the information that will help us decide that is this information about where the angle terminates. Pi over 2 and pi are the angles that bound the second quadrant. So in the second quadrant, sine is the only positive function. Therefore, excuse me, the cosine function should be a negative number. So cosine of theta is equal to negative square root of 3 over 2. In part C, we are given information about the tangent of an angle, and we're asked for information about the secant of the angle. There is a Pythagorean relation that relates both of those functions. However, I have not memorized it. So in order to get that relation, I'm going to start by writing down sine squared plus cosine squared is equal to 1. And then I want to have an equation that relates the tangent function and the secant function. The tangent is sine over cosine, so I'm going to divide terms by cosine squared of theta. Sine squared over cosine squared is tangent squared of theta. Cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared of theta. So we have the tangent of theta. So tangent squared of theta is 2/3 squared, or 4/9. And then we just need to add 4/9 and 1. So 4/9 and 1 added are 13/9. So 13/9 is equal to secant squared of theta. So that means that secant of theta is plus or minus the square root of 13 over 3. Now we need to use the information to decide whether it is positive or negative. Our angle is between pi and 3 pi over 2. That's in the third quadrant. In the third quadrant, tangent is the only positive function and its reciprocal, cotangent. So the secant function should be negative. So secant of theta should be negative square root of 13 over 3. Okay, in D, we have information about the cotangent of an angle, and we're looking for information about the sine of an angle. Well, cotangent and cosecant are related by a Pythagorean identity. That relationship is 1 plus cotangent squared of theta is equal to cosecant squared of theta. Again, that's not one that I remember, but I can generate very easily by dividing both sides of the original Pythagorean identity by sine squared of theta. So if cotangent of theta is negative 7/3, then cotangent squared of theta is 49/9. Combining together 1 and 49/9, we get 58/9. So that means that the cosecant of theta must be positive or negative square root of 58/3. Since our angle terminates in quadrant 4, cosine is the only function that's positive. Therefore, cosecant of theta must be a negative number. If cosecant of theta is negative square root of 58/3, then sine of theta is its reciprocal, which would be negative 3 over the square root of 58, but we can rationalize that and write it as negative 3 times the square root of 58 over 58.